Hi, welcome to xmTuition, where I help everyone with their physics homework. Like yesterday, outside the Hindu temple, this little girl asked me to explain this question to her. In this question, we have a spring mass system. If we use a lighter mass and a stiffer spring, the frequency of oscillation will be higher. Why is that so? So option A says that it's because the extension of the spring at the equilibrium position is shorter. Now, is it true that the extension will be shorter? Of course it's true. The weight is smaller and your spring is also stiffer. Definitely the equilibrium position will be higher compared to last time. But does this explain anything about the frequency of oscillation? I don't think so, yeah? So even though this statement is a correct statement, it's not the correct explanation for why the frequency is now higher. Let's look at option B, which says that the smaller weight of the bob results in a larger restoring force per unit displacement. Since this option mentions larger restoring force per unit displacement, let's think about the significance of this quantity. For any SHM, the graph of net force against displacement is always this downward sloping straight line passing through the origin. In fact, the gradient of this line is negative m omega square. So omega square is actually equals to the restoring force per unit mass per unit displacement. So if you want to discuss how the omega or the frequency changes, you should be talking about restoring force per unit mass per unit displacement. Just talking about larger restoring force per unit displacement is kind of incomplete, yeah? There's also another problem with this statement. The smaller weight of the bob actually doesn't affect the restoring force per unit displacement. It only affects the tension force at the equilibrium position, but the restoring force when you're away from the equilibrium position actually only depends on the stiffness of the spring. So if the option was to say that the larger spring constant results in a larger restoring force per unit displacement, maybe that would be a better statement. Let's look at option C. Does the smaller volume of the bob results in a smaller air resistance? Definitely. If your cross-sectional area is smaller, you catch less air, you experience a smaller damping force. But usually, the amount of damping is quite small and it doesn't significantly affect the frequency of your oscillation. So even though option C is a correct statement, it's not the best explanation for why the frequency is going to be higher. Let's look at option D, which says that the smaller inertia of the bob results in a larger acceleration per unit displacement. For any SHM, A is always equals to negative omega square x. So yes, omega square and therefore the frequency of the oscillation is directly related to acceleration per unit displacement. So does the smaller inertia results in a smaller A per unit x? Yes, it does, because for a spring mass system, the restoring force is actually negative kx, and therefore the acceleration is negative k divided by m times x. So for students who are very knowledgeable, they actually know that omega square is k divided by m. So the frequency of oscillation of a spring mass system can increase because of two reasons. Either the spring is stiffer or the mass is smaller. So option D is the correct option. Oh yes, thank you very much. I'm always glad to help. See you. Ta-ta!